Okay, today we are talking about how we can describe the graphs, what we want to pay attention to when we're describing a graph. We have been looking at rules, written in this case in standard form, regular form, not function form. Talk about situations, like we're subtracting 3 from whatever cash you have at hand. We've also been looking at tables of values, but today we're focusing specifically on how we can talk about graphs. So we're going to get rid of these other representations and focus specifically on the things we pay attention to when we are talking about graphs. So we're talking about the shape of the graph. Is the graph going to be a line? Is it going to be a parabola? Is it going to be some sort of repeating curve? Is it going to be a V? Talk about the shape. We might talk about whether it heads up or it heads the direction, whether it heads up or it heads down. So for example, this one we would talk about heading up, and this one we would talk about a downward facing parabola. Talk about whether it has symmetry. So symmetry is where you can cut a figure in half, fold it on top of each other, and both sides will be equal. These have symmetry right here, lines do not. Special points we pay attention to include where it crosses the x-axis, which is called the x-intercept, the y-intercept, which is where it crosses the y-axis, and then the vertex, which not all figures have, but it's the lowest or the highest point if the figure does that. And then whether it is a type of function. So all the slides you're looking at have a slides. Oops. Talking about. First one is a linear graph, and it's actually one of the ones that we worked with when we were ordering our functions the other day. This says that we're going to take x, the input, and divide it by 3, and then we're going to add 2. When we're looking at the graph, we comment on the shape. It's creating a line, right? So the shape and the direction is heading up. We can also say that it's positive. We read graphs from left to right, so you always look how it's growing. Now, a positive line you can think of as you're climbing up the line. The other two things that you want to pay attention to have to do with the special points. And the y-intercept right here is at 0, 2. And the x-intercept right here is at -6, 0. So you might describe this one as an upward-facing line or a positive line with a y-intercept of 0, 2, and -6, 0. In a couple of weeks, you'll also be commenting on how fast it's growing. It's called the slope, but that's something we'll talk about more later. This linear graph, also a line, so its direction is negative because it's heading down. It's a line. I'd like you to go ahead and try and find, here's my y-intercept. What is the point there? Here is my x-intercept. Not as easy to find. So if you can't see it really easy on the graph, you can always find the y-intercept by letting x equal 0. So if we put 0 in here, -2 times 0 is 0 plus 34. So our y-intercept is at 34. And if we are going to be finding the x-intercept, we would go ahead and replace the y, the output, with a big 0. Because then we would subtract 34 on both sides and divide by -2, and we would end up with this being 17, 0. So the y-intercept is always when x equals 0, and the x-intercept is always when y equals 0. Quadratic functions always have some sort of x squared in them. It's the highest degree. degree being the little exponent. Quadratics have a shape of a U, but it's a special name. It's called a parabola. Parabola. The direction of this particular one is heading up. There is symmetry, and where is the symmetry? We're going to go ahead and look at that. The symmetry for this one, I'll put in a different color. It's right there where it cuts it in half, and it goes right through this lowest point, and that lowest point is called the vertex. So the vertex for this particular one is at 1, 0, and the x-intercept is also at 1 and 0, because it's where it crosses the x-axis. The y-intercept is right here at 2. Nope, wrong one. It's 0, 2, not 2, 0. So it's 0, 2. The last one we're going to look at is an absolute value. Remember, this was the one that we were using when we were placing it in order. And this has got a particularly interesting one. The shape, because it is the opposite of absolute value, it'll always end up being negative, as opposed to regular absolute value, which always ends up being positive. So you're going to start with plugging in a point like, if we wanted to find the the y-intercept, we're going to let x equal 0, and we plug x in there. We've got 3 times x. Here's our 0, 3 times 0. That's 0, and so the opposite of 0 is 0, and you can see it right here. There is our y-intercept. It's interesting, this one, the y-intercept, the x-intercept, and the vertex are all the same point. So these are all the same point, and then there's other points. But this shape is a V, and it's downward facing or negative. There's symmetry right here at the y-axis. So you look at all of the defining points. You look at what's its shape, how it's facing, what is the symmetry, does it have it, and then comment on the points if they have. So, just to sum it up, look at the shape. Does it create a U? Does it create a V? Does it create a line? Does it create a curve? Does it create an upward-facing curve, exponential, or downward-facing curve, which is going to be happening in a couple of months? Direction, is it facing up or is it facing down? Can you cut it in half? There's more than one kind of symmetry, but we really focus on line symmetry. And then looking again, where does it cross the x-axis? And that's called the x-intercept. Where does it cross the y-axis? That's always when x is 0, and this is always when y is 0. And then, do you know if it's a linear function, a quadratic function, an exponential function, an absolute value function? Those are all the things you're going to be looking at. Last thing, I'm just going to change this to intercept, because that's what we're looking for. Intercept. And then vertex, I forgot to talk about, which is the lowest point when it's facing up, or the highest point when it's facing down. That's your vertex.